ratings, the severity score, and so on. So you can see that there's a medium, like all the way, probably somewhere close to the middle. Yes, that's where you see. So you get a medium risk rating. So that's probably one of the reasons why this response was actually blocked. Okay, but just remember, in production, when you have blocked responses, please handle them gracefully, right? So please handle them gracefully. Okay, so that's safety. So safety is imperative. Let's move on, right? So we are on task 6 out of 12. Okay, don't worry, because the next few tasks are more straightforward and they actually may take a bit to run, so I'm not going to run them live. Okay, so we have the output to show you. Okay, so this next section is actually a multi-turn chat. Okay, so this is basically a bit more of an advanced interaction pattern that you can actually use with Gemini, all right, with the Gemini API. So a chat session, you can create it, then actually subsequent messages will be sent through the exact same object. So this helps you preserve conversational context. So you don't have to like put a cache, manage your context, and keep prompting and creating like a huge like a prompt by caching all previous responses. So you can actually do this multi-turn chat. Okay, so in this case here, basically what happens if you look in the cell here is that they do two things, right? It starts with generating a code. Okay, this code is a simple one that writes a function to check whether a year is a leap year. So that was the first part. Then the follow up. So if you scroll down in the notebook, okay, so you can see that the output came out. So they test a function. This is a Python implementation. Okay, don't need to go through the details. You can run through this on your own. Okay, but there's a follow up check. Okay, so they say write a unit test of the generated function. Okay, so because we sent it to the same chat object, so it already has that context, right? So when you follow up with this, write a unit test of the generated function, the model actually remembers that it wrote a leap year function, and that generates the appropriate test. So this is really essential because it allows you to build like interactive assistance. You can see the response there, so you can see the function is being that. So very often we talk about context problems when you use large language models in production. You talk about data concerns, but if anything, you should really use large language models. You should use Gemini to actually run testing, right? Because testing is very, very standardized as an environment. So testing is great. It's a perfect use case for actually large language models or Gen AI. Okay. So next, okay. So now that we have seen this multi-turn chat, the next example is about async requests. Okay. So async request uses this interface called client.aio, okay, or async IO. All right. So it actually mirrors the async versions, but rather the synchronous versions, it mirrors the application, but it allows non-blocking execution. Meaning, because when you're using services real time, you might suffer network interruption. Some things might take a bit longer, so you need non-blocking executions, right? So it's simply just creating this AIO, right? So it's very, very simple. So here they're asking, compose a song about the adventures of a time-traveling squirrel. So when you run this out on your own time, okay, on your own time, it might take a while, but you can continue to proceed with other work because it's async in nature, right? That's the wonderful song that comes out with. All right, okay, so that is async. Okay, so we are almost more than halfway through. Hang in there, guys. Next section. Okay, the next section actually highlights multimodal capabilities, and this is where Gemini really truly shines. It can process images, audio, video, PDFs, web pages, not just text. All right. So if you talk about local images, okay, you can actually read it from disk, or you can send it to cloud storage. In this case here, we use cloud storage. Right, and then we can ask it to do a simple task. So in this case here, we loaded an image from cloud storage, and what we wanted it to do, what we wanted Gemini to do, is to write a blog post based on this image. Right, so the model will see the image and actually generate a relevant blog post about healthy eating, meal prep, and so on. Right, so that's what multimodal processing is. Okay. Okay. So the next thing here, okay. Documents stored in Google Cloud Storage can also be provided. Okay, so it allows models to like summarize research papers, anchor reports. So in this particular code block, to use PDFs, we can actually just use the part dot from URI with the cloud storage. Okay, so use this part library so that you can specify the syntactics of this input. All right, and if you went through this, actually this is the very world famous, very seminal paper called attention is life. All right, I'm sure most of you here will have actually read this paper, or at least heard about it. Okay, this is a paper that made it all happen, right? Made it all possible. Right, so Gemini actually can summarize the whole entire research report documents. Right, so talk about like the coder encoder, multi-head attention, attention, and so on and so forth, position encodings. I think by now you should have heard this to no end, right? Because it's so popular. All right. So let's move on. Okay, so you have also seen this multimodal, right? So there's also audio, right? Audio files from public URLs can be summarized, analyzed with timestamping. You can send YouTube URLs. It analyzes the video content and can tell you exactly what happens at specific timestamps. If you've used like, for example, Google Meets recently, you also know that there's automatic summaries and all. This is all video analysis, right? So you can do that, but even if you have no issues with resource exhaustion, this will take a while because it literally runs through the whole content that is actually being passed. So just be mindful. So all these things are more async in nature, alright? So that is the video content. Okay, so the particular video content is some QCon podcast. Alright, and then you have a video URL. So this video URL, if you see, oh, it's like Harry Potter, right? Because the prompt actually kind of alludes to the fact that at what point in the video is Harry Potter shown, right? So we didn't give it context, but it is enough for it to actually analyze and tell you, hey, exactly characters from Harry Potter is shown at the 57-second mark. Go verify this on your own. This is something that easily verified. Click on the YouTube link, go to the 52nd mark. Okay, so it's Harry Potter there. All right. Okay. So next section. Okay, next section. Okay, so basically here we can see that you have this URL. Okay, so we can also send these URLs and allow it to actually analyze that. So in this case here, we are sending a text HTML file. All right, so it's like a generative AI documents, a documentation page. Very, very useful, right? Because these are things that can help you summarize. So I'll move on because I think these are relatively straightforward applications. So I want to talk about control generation, okay, because these are things that might be a bit new to you, okay? So when we talk about control generation, right, you basically helps your model or running control your model to give a predictable, machine-readable structure in terms of the output that it generates. This is especially important if you know you're a developer, you know how important it is to have like kind of like a standardized API for communications, for interaction between services, applications, and all that. So that's where control generator output comes in. So this is where you can see in this particular code cell, you see this thing called Pydantic. All right, so Pydantic, you can allow, like you create a recipe with a few fields like the name, the description, the ingredients. Then the request says exactly that, hey, I want it to be in a JSON format. All right, it must give you a JSON, and you must follow this response schema that we have earlier defined from lines 4 to 7, right? So if you actually scroll down, the output gives you exactly that, right? So it is a JSON. Okay, of course the JSON maybe has nested, but still the top level keys are all actually structured as you have actually requested it. So you can do this, then you can take this JSON and actually manually pass it later on, or pass it to another application that knows what to read for, right? So this is control generation, which is really, really important. Okay, so let's move on. Okay, let's move on. So you can pass the strings as JSON and so on. I'll leave it to you all to actually look at the different fields that are available, because I do have a couple more tasks that I want to look at so that you have an idea. Okay, so like you have count tokens, right? Tokens is budget, right? Tokens is all about how much you can spend, how much your budget has. So count tokens, very simple. Count tokens literally tells you when I run this, how many tokens will I consume? Okay, this is actually before you even actually run the model. So this is great. Okay, so before you actually send a request to the service called Gemini, you can actually count your tokens and see exactly how much you're going to consume. Then, if you move on, there's this Google search tool. Again, very, very popular. Okay, it's all about grounding. So the Google search tool allows you to actually include current information. So the context for this particular code cell is actually current temperature in Austin, Texas, right? So all you need to do is actually configure this thing called tools, right, which is on line 7, okay? So you can see that line 7, you have this tools, it's called Google search tool, but where do we define Google search tool? So the Google search tool for this particular case was a built-in tool, okay? It's something called Google search. You can define your own custom tools as well, okay? So this is where we actually included Google search as a tool in the request configuration. So if you see after the response is generated, the grounding metadata is actually printed, alright? So this is where the search was actually being used, and the rendered output actually tells you where the search entry points supported the model's answer, okay? So this is where you need, this is especially important for applications that kind of depend on live facts, or you have rapidly changing conditions. So this is important. Okay, I know it's almost time, but let's run through function calling. Right? Function calling is basically the ability for you to actually interact with developer-defined functions, right? So you can describe a function in code. So it's like a Python method that returns weather. That's the example that we're given here. Right? So setting temperature to 0, why do we set the temperature configuration to 0? Because we need deterministic and consistent outputs. Okay, so this kind of mechanism allows you to actually combine your large language model or language understanding, natural language processing with your programmatic logic, such as database queries, your business rules, your external APIs. That's where your function calling is really important. Then, following this function calling, there's this open API style declarations. So what open API style declaration is basically telling you, for you to give you some more control, so that you can actually define how the function, what functions to call, what are the arguments that are required, and so on. But open API declarations are all in natural language, so you have to define it properly so that the language models knows how to parse this properly. Okay? Last bit. Okay, so last bit here you have code execution. So code execution is really actually provided the same way as a tool, the same way as function calling. So once you actually provide it as a tool, like you can see in line 7, which is the code execution tool, as defined in the first line, where you have code execution equals to tool code execution, alright, you can use it, alright? So in this particular example, it asks the model to actually compute the 20th Fibonacci number, right? And then determine the nearest palindrome. If you don't know what these are, search it, ask Google Gemini, alright? So these are just very, very common math concepts here, alright? Okay, so that's it. Okay, so that's the intense lab that I tried to go through in like an hour, okay? But I hope you go back after today and actually run through this on your own. So just do a quick recap of what we did so far, alright? So we have like done a lot of tags, we went through some of the customizing some of the model behavior, maintaining context, multimodal capabilities, structuring your output responses, and also like function calling, tool calling. These are all essential building blocks for your production AI applications. I would love to go through these in more detail, but we do not have the time for it for today. So go back, go and run through the workbook again, go through the notebook again, and please be sure to actually complete all 4 of your labs before 13 January, 13 Feb, so that you can actually receive a very special credit badge, your bragging rights on LinkedIn or your social media. Alright, so be sure to do that, and thank you for joining us today.
back, everyone. Congrats, you've made it to the halfway point of day one. And to anyone who's just joining us now for the afternoon, we're so happy you're here. I'm Abhi, Staff Developer Advocate here at Google Cloud.
And I'm Durajo, Developer Relations Engineer. It's been an amazing start of day one of our onboard edition.
And the energy has been electric so far. I'm still thinking about May's customer agents demo, a fully functional agent with hardly any code. Wow.
That's incredible, right? So how fast things are moving is like really amazing. And William and Natasha's Gemini Pro Light Lab really brought that to life. So with the reasoning capabilities, it's really proved the power of our most versatile AI model to date.
And we hope you all enjoyed the opportunity to get hands-on. We've also been keeping an eye on the chat and the questions are rolling in. Keep them coming, ask some architectural questions, deep dives.
Yeah, and we have a couple of quiz questions so far. So let's take a look at how you did it.
Which component of Google Gemini Enterprise platform enable users the access to Google's most advanced multimodal AI? What do you think?
Could be the brain, you know.
Yeah,
Let's take a look. All right. Yeah, most of you get it right. Great job. And the second question is, what are the reasons why you would combine keyword search with the semantic search? What do you think, Abhi?
I know the answer, but yeah, let's see if the audience have got it right. I think it's to cover keywords the embedding model doesn't understand.
Let's take a look. You're right. All right.
Yeah, the audience got it right too.
Yeah, this is crazy. Okay, let's do it.
We have a couple more questions coming up across this afternoon sessions, so keep your eye out. But for now, let's dive into what's coming up in the second half of a day. I hope you're all ready. We've set the stage with the agent ecosystem, but now it's time to get down to business.
That's right. So the first half is about designing the agent, but for this afternoon, it's all about deploying it. So we will start with the essential developer tools, and then the infrastructure you need to actually run this workload.
Kicking things off with Cloud Run, Andrew will look at how to unlock generative AI. Then Chandrika will follow this up with a deep dive into building complex multi-agent workflows with Agent Development Kit.
And of course, you can't deploy a skill without a secure environment. So next up, we have a crucial overview session about security in the age of AI by Colin.
That's awesome. For those of you itching to code, get your dual monitors ready. We have a live lab focused specifically on remote agents with ADK and the agent to agent SDK, which is A2A. And our expert instructor for this one is our very own drumroll, Tuya.
Yeah, it's going to be the fun one, but an important reminder, if you want to join me but haven't set up your special lab classroom access in explore.quillab.com, you can scan this QR code that you see on the screen right now. Then you are able to hit the ground running when the session starts. So you have just a few minutes to do this, so you do it now, right? And just remember to use the exact same email address that we use to register for the Cloud Technical Series event. And if you need any extra direction, any help, check out this participant guide that is available for you in the resources tab at the top of your screen.
Awesome, can't wait. And finally, stick around until the very end because we're wrapping up day one with a highly anticipated Ask the Experts session. We are still taking questions in this chat, so make it meaningful, make it count for you, and if anything comes across to your mind this afternoon, feel free to drop them in there.
Yeah, so for now, we will take a quick break to let you stretch, grab a coffee, and reset your brain. If you have any extra time, you might also want to check out this additional learning opportunity that we have included for you during the break time. So one of these is if you want to be the first to join our brand new initiative, Gemini Enterprise Agent Ready, formerly known as GEAR, and more. But don't worry, we will also chat about this in the next step at the end of the day as well.
We'd appreciate also if you could let us know what you thought of the onboard program from here within the platform itself. We truly take all your feedback to heart and use it to build even better learning experiences for you.
Okay, So that's it for now. We will see you back here in about 5 minutes. Let's start deploying.
this session. My name is Andrew Dole, the technical lead from the application modernization team from Google. In the next 20 minutes, I will be gladly introduce to you our latest development for Cloud Run and how you can deploy and serve your AI applications using Cloud Run in just a few minutes. Okay, so let's start with a quick introduction of what Cloud Run is, and probably the best way is to position Cloud Run among family of other services that Google Cloud provides to our customers for an end-to-end development lifecycle of an AI application, from ideation, deployment, running of your applications, and even day-two operations. So zooming to these services that help you to run your applications, Cloud Run is one of the popular options, such as Compute Engine, or GCA, or Container Platform, or GKE in short. So these services enable you to deploy and run your AI application in a scalable and secure manner. A deeper look into Cloud Run. This is more of a fully managed and serverless service where Google takes care of the setup, configurations, and maintenance operations. So you simply provide your code in either a container or functional format. We will then run your application and then scale the needed resources according to the demand of your applications. So why should you use Cloud Run? As a fully managed and serverless platform, Cloud Run takes care of most of the operational tasks for you. So you can just focus your precious resources on your code, the actual differentiator for your business, and less on the infrastructure, which has become the level field for all competitors. So by uploading these non-value differentiating tasks to Google, you would then be able to achieve 95% faster in deploying your application. Cloud Run also provides resources with redundancy by default. This means the infrastructure reliability is set up and maintained by our SRE team from Google. The resources from Cloud Run are auto-healed if there are issues, which help to minimize application interruptions by 98%. As the serverless platform, Cloud Run scale the resources up and down, matching to the demand of your code. Especially, Cloud Run scale down to 0 when there are no traffic. This means you can optimize costs to exactly what your application needs, estimated to be around 15 to 50% less than the platform that otherwise you would need to provision and manage yourself manually. So in 2025, Cloud Run announced support for GPUs. So with all the benefits of a serverless platform, including full integration to other popular AI development platforms such as Vertex AI and database platforms such as AlloyDB or CloudSQL, makes Cloud Run the ideal runtime environment for AI application development. So while Cloud Run has been known to be simple and suitable for many event-driven workloads, there is a lesser-known fact that Cloud Run is not only safely secure and maintained by our famous Google SIA team, but also can scale to enterprise-grade level. This Cloud Run also a suitable platform for diverse enterprise-grade workloads. We also announced the consolidation of Cloud Function to be under the same family of Cloud Run. This makes Cloud Run the one-stop option for all serverless applications, be it in a container or functional format. This also allows Cloud Run to support large variety of languages, frameworks, and libraries while stays open and portable. This makes Cloud Run actually the go-to platform for many application developers. So with the design philosophy of being open, Cloud Run allows you to run a large variety of AI applications, be it the model that you develop yourself, or an open source model, or the model that you have just fine-tuned from a foundational model. So Cloud Run provides multiple approaches for you to download and make these models ready for your application to load and serve. So while Cloud Run has been designed to optimize costs by scaling down resources as fast as possible when the traffic reduces, we have also been improving our platform to spin up new resources as fast as possible. So our benchmark tests show that Cloud Run scaled from 0 to an instance with GPU and needed drivers installed in 5 seconds. This is crucially important to keep the customer experience in high quality. As a developer-centric platform, the ability to spin up resources quicker make Cloud Run a very friendly platform for quick experiments, which has been the key for successful AI applications. Comparing to other container platforms, which may take up to 20 minutes to provision, Cloud Run can do the same in minutes. This makes rapid tests possible and improve the development productivity by multi-folds. So in this session, let's explore practical reference architecture that our customers are using Cloud Run for their AI applications. And you can follow the same best practices for your own applications. We'll be looking at two commonly used design patterns for serving AI application on Cloud Run. On the first pattern, Cloud Run will be used as an entry point service for all requests. Cloud Run then route the request to the backend LLM models hosted outside of Cloud Run. Popular options for these backends can be either on Vertex AI or GPT, or basically any reachable endpoints of your application elsewhere. This pattern provides the abstraction of the backend, provide you the flexibility to switch between different platforms for the backend if needed. On the second popular pattern, Cloud Run is used for both serving as an entry point and hosting the application itself with the new GPU support. In this pattern, you will be able to utilize the unique support of Cloud Run, a serverless container platform, for AI application utilizing GPU today. This pattern provides the simplest architecture where both components are hosted by Cloud Run, providing the benefit from flexibility, control, and cost optimization end-to-end. So, given Cloud Run with the GPU support, this actually opened the possibility for you to build and run a variety of AI applications. Let's explore popular use cases that our customers are building. First is real-time multimodal inference. So for example, imagine you want to run a chatbot application for your end users, but at the same time, they want to generate images using text prompts. So your chatbot should be able to support both text and image generation. You can also use Cloud Run to deploy AI agents. Take an example where you want to run an IT support agent or customer service agent to autonomously answer your users' questions. Cloud Run GPU service can also be used for non-AI compute-intensive workload, such as media serving for your videos, audio, or image files, or even 3D rendering for game development. If you are looking on the slide, on the right-hand side, you will see Cloud Run jobs. This will not be covered today. However, at a very high level, for use cases where you need resources for a longer periods of time, such as a small-scale model fine-tuning, training, or batch inference, or simply accelerating background tasks, Cloud Run jobs offer a simple and cost-effective option for these use cases. So now, let's deep dive into a use case which is the talk of 2025 and will continue being the focus of our customer in 2026, AI agents. So among other options, Cloud Run provides the simplest and cost-effective option to host your AI agents. Cloud Run can host a scalable and reliable serving and orchestration layer. And at the same time, it can integrate with multiple needed backend services, such as the core AI model, which can be either Gemini API or the model endpoints from Vertex, GPT, or Cloud Run itself. Cloud Run also supports integrating with the needed memory store, vector database such as Outskill or AlloyDB, and any other required tools to develop your AI agent. Cloud Run also supports LangGraph and Agent Development Kit, or ADK in short, which are popular solutions to develop AI agent applications. So along with simple operations, Cloud Run with NVIDIA GPU also offers strong performance. We keep our infrastructure latency to a minimum so that you can get the best performance while serving your models. The table on the slide show cold start times for multiple models with the Ollama framework, ranging from 11 to 35 seconds. This measures the time to start an instance from 0, load the model in the GPU, and for the model to return its first word. So, being the serverless and fully managed service offering, Cloud Run makes it absolutely simple for you to deploy your applications. It adds a couple of clicks on the console and a single checkbox to enable GPU support, or through the programmatic approach such as the YAML file or the gcloud command on the terminal. In the next sections, let's have a quick look at a customer right from this APAC region who has been successfully utilizing Cloud Run for their AI application. With Cloud Run GPU support, Vivo have been able to experiment multiple AI applications with quick iterations, with multiple models and multiple deployments within a day, allowing Vivo to quickly identify the application that works best for their customers. Vivo gains the greatest benefit of Cloud Run in reducing the operational and maintenance costs, which allow the team to focus more on the application itself. The ability to scale fast and scale to the great enterprise level improve the performance and reliability of the application, enabling Vivo to expand their business overseas efficiently. In the next section, let's see Cloud AI application in action through two demos. So, in this first demo, let's have a look at the reference architecture of how Cloud Run can be used to generate image. In this architecture, we will see that there will be a Cloud Run instance with L4 GPU. And in this architecture, we're going to use top serve, which is the serving layer of the architecture. And for the model itself, we're going to utilize Stable Diffusion XL to generate our image. Alright, so let's have a look at what I needed to build our application running on Cloud Run. First thing, because this is a Python application, so we're going to have a requirements text file. And in this requirement text file, we are having the necessary libraries, especially if we are looking at the transformers and the diffuser, which are basically the models that we are going to use to generate our image. We're going to also include the libraries so that we can interact with cloud storage to save our image after it's being generated, and also the necessary library to interact with NVIDIA GPU. This config property file basically contains the parameter that required for our applications. For example, the port that the service will listening on, as well as other parameters defining the number of workers that is going to be needed for our model. Moving forward, this is basically a very standard Docker file to generate the container image. In this, you will be able to see that we have a section to download the model, and then we also archive the model into our cloud storage, basically copying over the property file and also the Python code that we're going to go to in just a little bit. This is basically the logic of the applications, right? Our Python code. In this Python code, we basically receive the text prompt, and then we transfer that and then feed that into the models to generate the image. In the logic to generate the image, there are actually two main steps. First step is going through an API, which is a pipeline to generate the first image, the draw image. And then we're going to utilize the second API, which is a refiner, to actually fine-tune, refine the image that was generated in the previous step. So very simple. After we generate and refine the image, we're going to return the image back to the caller. All right. So the way that we're going to build the container image is very similar to any other container platform like Jiki or Cloud Run. We're going to utilize the build command to generate the image, and then we can just run the deploy command to deploy our image to Cloud Run. To speed up the time for us, in this session, I already have the service deployed and is running at the moment and ready to serve our request. And if you paying attention to the below panel, you will see that we just specify the variable service URL to the service that we just deployed. And then we prepare a prompt text with that we want to generate an image of a dog running in the park. And then we can measure the time for the service to actually generate the image. And in this demo, you will see that it took 16 seconds for the image to be generated. And after the image generated, we'll be able to verify it. It actually saved into cloud storage itself. And you see, we have the image of the dog running in the park exactly to matching with our request text prompt. In the next demo, I want to demonstrate to you the ability for Cloud Run to scale. This is, as I mentioned in the previous slide, the lesser known fact, right? So in this case, we're gonna scale the number of clients from 0 to 100, and we're gonna observe how Cloud Run actually scale the needed resources, in this case, GPU instances. So if you are paying attention to the middle of the screen, you will see that while the number of load generator client increase, the number of GPU instances also increase accordingly to ensure that we have enough resources to serve the request. Also pay attention to the middle screen where we show the number of images generated per second, as well as the latency for each image to be generated. As you can see, while the number of clients increase, the number of GPU instances increase, we also increase the number of images can be generated in a second. And at the same time, the generation latency also start to go down. This means we will be able to provide more resources to generate more image per second, but at the same time, improve the performance by reducing the latency to generate an image. So in just a little bit, you're able to see that in around 4 minutes, we would be able to increase the number of instances from 0 to over 100. And then it crossed 100, right? So what can we learn from this demo? Basically, while we are receiving more and more load from our clients, Cloud Run will be able to scale to hundreds or even thousands of GPU instances in just minutes. It may take other platform a good 20 minutes to just provision one VM, right? Or the one cluster. And at the same time, the number of images per second and the latency metrics are also improved. All right, we have reached the end of our demo. We also have additional resources that can help you to build and deploy your application quickly and efficiently on Cloud Run. So please scan the QR code below to find those links in the detail. So that's our quick introduction to Cloud Run, and with the support of GPU, Cloud Run provides the developer-centric platform for you to quickly deploy and run your AI application in just a few minutes. I hope you have learned a few new things from these sessions, and we are looking forward to your feedback to continue to improve our content to be better. Until we meet again, thank you and have a great day.
we are moving from simple AI models to agentic systems that can reason, plan, and execute complex tasks on your behalf. This is a significant advancement that is unlocking new opportunities for innovation. Hello everyone, my name is Chandrika Kadirvelmani, AI Principal Architect at Google Cloud. In this session, we will provide you with a comprehensive guide to building the powerful agentic AI applications on Google Cloud. An AI agent is an application that attempts to achieve a goal by observing the world and acting upon it using a large language model and the tools that it has at its disposal. So how does it work? At its heart, building an AI agent is all about connecting a powerful AI brain like an LLM to the tools it needs to get a job done. These tools can be your company's APIs, your internal data, or even other specialized agents. To set one up, you first teach it what you want it to do using plain English instructions and a few examples. Then you give it a memory so it can remember context like your past conversations. Finally, you teach it how to plan, how to break it down, a big complicated goal into smaller manageable steps. And that's all. Once you put all that together, you have a functional AI agent. You can ask it to do something complex and it will start working on it in the background. It might go through a dozen different steps on its own before it responds, like delegating a subtask to another agent, looking up facts, or even popping back with quick question to clarify something within you. But as developers, let's translate that into a code. What does this actually mean for us? A standard call to an LLM is a single stateless transaction. You call a function like, for example, model.generate underscore content. You send a prompt and you get a response back. It's a simple request response. An agent in terms of code is fundamentally a loop built on top of that API call. It's not just any loop, it's a reasoning loop. This pattern is often called the React loop, like reason and act. It looks something like this pseudocode. The loop continues as long as the user's goal isn't met. Inside the loop, we first enter the reason phase. We ask the model, give everything we know so far, what is the next logical step? The model might respond with a final answer, or it might respond with a request to call one of our tools, like a function to look up a stock price, for example. This brings us to the act phase. Our code checks the model's output. If it's a tool call, we pause, execute our own Python functions, take the result and add it to our context or state. Then the loop repeats, sending that new information back to the LLM for the next reasoning step. So here's the key takeaway for the developers. The LLM is the brain, but the agent is the loop. It is the orchestration code that turns the LLM's reasoning into a series of actions. Now, looking at the loop, you might be tempted to just write it yourself. But as you build, you hit the same hard problems everyone hits. You have to manage state and memory. You have to write fragile code to pass the model's output to see if you want to call a tool. You have to figure out how to orchestrate workflows when agents need to talk to each other. And you end up writing the same boilerplate plumbing code over and over again. This is the exact problem a framework is meant to solve. And that's where the ADK, the Agent Development Kit, comes in. The ADK is an open source framework that designed specifically to handle the complexity of that reasoning loop for you. It provides the structure and tooling to manage state, handle tool calls, and orchestrate agent collaboration, letting you focus on the unique logic of your application, not the plumbing. It gives you the building blocks to create agents that are capable, autonomous, and even work together. When you start building with LLMs, you have several options for how to approach it, each with different level of abstraction. At the lowest level, you have the DIY approach using direct REST API calls to the models. This gives you maximum control but requires you to handle everything yourself. Moving up, you have low-level LLM framework like the Google Gen AI SDK, which simplify the process of calling different models. They come the low-level orchestration framework like LangChain, which help you chain those calls together into simple workflows. The agent development kit sits at the level 3, providing a true agent framework. It handles not just the calls and orchestration, but also the more complex agentic capabilities like the state management, planning, and multi-agent collaboration. ADK is designed to give you the power of high-level framework while keeping the development process transparent and manageable. Once we deploy, we need to give access to the, Once we deploy, we need to give access to the users. Without a standard, we face a fragmented experience. Every agent ends up with a different custom front-end, creating a disjoint user journey. This leads to integration nightmares where we waste time building boilerplate code and governance gaps caused by unmanaged access across scattered apps. Gemini Enterprise solves this as one portal for all AI agents. It acts as a seamless bridge, separating the backend brain from the front-end face. In just 4 steps, deploy, create, app, register, and launch. Users can immediately start conversing in a secure, polished interface. No front-end code required. We can build complex, code-heavy agents on the Vertex AI and simply register from here. This unlocks open orchestration, meaning our agents can collaborate. It also provides centralized lifecycle management to update agents instantly, all while enforcing the governance, which is crucial for an enterprise. So this, whatever I explained, right, comes at the end. So we are just going back to the ADK. ADK is a software framework designed to simplify the creation of multi-agent applications. So the dev UI provides a graphical interface for developers to build, test, and debug the agent. The tools allows you to easily connect your agent to thousands of tools, APIs, and data sources. It allows you to combine deterministic logic with the Gen AI capabilities. This ensures your agent is reliable, testable, and safe, and is very important in an enterprise context where you may need to be 100% sure that you get predictable outcomes. So it is model agnostic, supports any generative model, and it is optimized for Gemini as the default. And you can use it for a wide range of use cases, including not only your typical chatbot type solution, but also agents that perform tasks in the background, and also multi-modal agents that use streaming audio or video. Let's get into the core concepts. The core of ADK is the base agent class. We provide 3 primary categories of agents you will work with. Let's start with the LLM-based agents. These agents use a large language model as their core brain. They leverage the reasoning and evaluation capabilities along with a set of tools to determine the best course of action to achieve a given goal. Second, we have a workflow agent, the orchestrator, which executes tasks in a specific order, much like a traditional software workflow. As you can see, these workloads can have different execution flows. They can be sequential, run in parallel, or use conditional logic to make decisions or operate in a loop for iterative tasks. Finally, we have custom agents. This category represents a more hybrid approach, combining custom logic and code with the power of LLM-based components. This gives you the flexibility to build highly specialized agents that are tailored to unique or complex tasks. The most fundamental building block in the ADK is the LLM agent. Think of it as the brain. You define it with 4 key properties. A unique name, the model that will do the thinking like Gemini, a description so other agents know what it does, and most importantly, the instructions. The instruction is the detailed prompt that tells the agent who it is and what its job is. Getting this right is the most critical skill in agent development. Technically, a tool is typically a modular code component like a Python function or a class method. To equip an agent with a tool, you simply pass the tool into the tool's argument during agent creation. We'll see more on tools later. So meaningful multi-turn conversations require agents to understand context just like humans. They need to recall the conversation history, what's been said and done to maintain continuity and to avoid repetition. The ADK provides structured ways to manage this context through session, state, and memory. Session is the current conversation thread, represents a single ongoing interaction between a user and an agent system, contains the chronological sequence of messages and actions taken by the agents referred to events like during that specific interaction. A session can also hold temporary data that is relevant only during this conversation. State is used to manage information relevant only to the current active conversation thread, example, items in shopping cart during this chat. Memory represents a store of information that might span multiple past sessions or include external data sources. It acts as a knowledge base the agent can search to recall information or context beyond the immediate conversation, which is managed by a memory service. Beyond just storing data, robust agents need structured ways to record actions, manage files, and allow you to intervene in their logic. ADK handles this through events, artifacts, and callbacks. So an event in ADK is an immutable record representing a specific point in the agent's execution. It captures user messages, agent replies, requests to use tools, etc. An artifact in ADK is a managed resource representing a specific file or binary object associated with a session. It could be any PDF document or generated images or audio files, anything like reports. A callback in ADK is a developer-defined hook that representing a specific intervention point within the agent execution lifecycle. It enables the injection of custom logic at critical moments, such as before a tool runs or after a model replies, facilitating the tasks like logging safely, validation, debugging, and external system. But how does ADK coordinate all these components together? Like, think of the ADK runtime as the engine of your agentic application. You define the parts, agents, tools, and the runtime handles how they connect and run together to fulfill a user's request. The runner receives a user query and asks the main agent to start processing. The agent and its associated logic runs until it has something to report to, like a response or a request to use a tool or a state change. Then it emits an event. The runner receives that event, processes, and any associated actions like saving state, and towards the event onwards, example to the user interface. Only after the runner has processed the event does the agentic logic resume from where it passed, now potentially seeing the effects of the changes committed by the runner. This cycle repeats until the agent has no more events to yield for the current user query. In event loop is the core operational pattern defining the interaction between the runner and your custom code like agents, tools, callbacks, collectively referred to as execution logic. You can run your ADK agent with an interactive command line interface using the ADK run command or the ADK web user interface that is shown in this snapshot. And you can view all the components that we have so far discussed here. So this gives you a very easy debugging during your development phase. Next comes the tools. A tool represents a specific capability provided to an AI agent, enabling it to perform actions and interact with the world beyond its core text generation and reasoning capabilities. ADK provides a rich ecosystem of tools, like it has pre-built Google tools like Google Search or Vertex AI Search or RAG. And we have integrations for popular third-party libraries like LangChain or Crew AI, but the most powerful feature is the custom tools because you can turn any Python function into a tool, right? But why you all need a framework? You can just go and write your codes, right? The answer is, if you don't have standards, we end up in a spaghetti junction of custom integrations. So let's start with the first one, the Model Context Protocol, or the MCP. So MCP is an open standard serving as the API spec for the AI tools. It connects agents, that is the clients, to the tool servers by standardizing two key actions: the discovery, like what tools exist, and execution, run this tool. Think of it like a REST API for agents, simply replacing get and post. ADK integrates with MCP using a standard producer-consumer pattern. As an MCP client consumer, your ADK agents connects to an existing MCP server to instantly access external tools like databases or API, and it can be streamlined through a single class like MCP toolset. By simply adding it to your agent's tool list, it automatically handles connection, discovery, and execution behind the scenes. There is no complex setup, just initiate this class, and you will agent instantly gains full access to the server's remote capabilities. ADK also simplifies the reverse, that is exposing your tool that as a MCP server, that is a producer. You define your logic using standard function tools and ADK utilities and automatically translate them for the MCP server. This setup acts as a bridge, seamlessly converting incoming MCP requests into native ADK tool executions. MCP defines the language, but we still need a transport for the wire. There are two primary connection methods. The first path is the standard IO. This is for your local development. It runs the server as a sub-process, but it doesn't scale, right? So for production, you have to use the HTTP network, which is the standard, and your agents connects to a standalone service via URL. This provides high scalability. So next, we have seen the power of MCP, but if agents can simply expose their skills as tools, you might ask why we need a specific protocol for them. The answer lies in a critical distinction: agents are not tools. So let's look at why it matters. Agent interactions are fundamentally different because they are unbounded and conversational, allowing for back and forth clarification and autonomous background work. This is where the A2A protocol comes in as the open standard for agent collaboration by using agent cards for discovery and standard web protocols like HTTP for communication. It enables independently built agents to find each other, and delegate tasks and coordinate effectively on complex goals. So how the life cycle of an A2A interaction happens, right? The flow moves from left to right, starting with the user interacting with a client, which sends a request to agent A. Agent A then connects to agent B, which is the remote agent. A critical concept here is that the client and remote agent are just roles, not fixed identities. The system is designed for collaboration. For example, if agent B needs extra data to fulfill a request, it can switch roles and act as a client to call a third agent. But before any interaction happens, we need discovery. This is handled by the agent card, essentially the agent's digital business card. It's a standard JSON file, and that defines the agent's identity, endpoints, authentication, and specific capabilities. So once connected, the conversation begins, and the first message agent A sends the object containing paths, which can be text or files or JSON. While we usually use the HTTP REST, the protocol is transport agnostic. If the request is complex, we don't want to block the connection. Instead, the backend managed by the agent executor creates a task, and agent B immediately returns a task ID and status, allowing the client to track the life cycle from submitted to completed asynchronously. Finally, we have the artifacts and streaming. The results are delivered as artifacts. So to improve the user experience, we support streaming. So to expose your agent, simply wrap your standard ADK definitions in the A2A function. This one step automatically configures the executor and generates the agent card from your existing details, making the process practically magic. To consume a remote agent, Simply use the remote A2A agent class and point it to the agent card URL. The ADK handles all the communication logic, allowing you to use it in your sub-agents list exactly like a local agent. So you can deploy your ADK agent to Cloud Run or anywhere else, including GKE or Docker, anything. Vertex AI Agent is an enterprise-ready, comprehensive managed platform specifically designed for agentic workflows. It supports other popular agent frameworks like LangChain, LangGraph, other than Google ADK, which provides hooks into any model in the model garden and allows you to bring any tool you need. Crucially, it provides managed service for the hard parts: session management, memory, observability, and evaluation. Cloud Run is an enterprise-ready, fully managed serverless platform specifically designed for deploying containerized application at scale. It supports any programming language, library, or framework, including ADK, provides seamless authentication to Google AI services, and allows you to containerize any system dependency you require. So this is an example multi-agent architecture on Google Cloud, leveraging the Google Cloud's agentic stack. To summarize, we have discussed the Google Cloud's agentic stack covering ADK, MCP, A2A, Vertex AI agent engine for deployment, and the Gemini interface to give a common governed UI interface for all your agents. Right? And this is an end-to-end agent development and productionalization on Google Cloud. Thank you all for your time and engagement today. The key takeaway I want to leave you with is this: we are moving beyond just building isolated chatbots. With this stack, you have all the tools to build scalable, interoperable, and secure agentic systems that can truly collaborate and solve complex problems for your enterprise. I hope you feel equipped to start building your own agents, and we love to hear about what you plan to build next. Thank you.
afternoon, everyone, and welcome to our Cloud Technical series. From all the sharing you have heard from my colleagues around AI and all the evolution of AI, I'm sure you will agree that we are standing at a massive inflection point. AI is no longer just a feature, it's becoming the operating system of modern enterprises. So before we rush to adopt all these tools, a critical question that arises is that are we safely securing our innovations? I'm Colin Low, and I'm a strategic architect at Google. Today, I'm going to walk you through how we can secure our AI lifecycle without hitting the brakes on our innovation progress and empower your organization to leverage AI with confidence. AI is actually at the heart of all this transformation. 92% of organizations are currently evolving all their IT operations to adopt modern platforms and technology. Whether you are streamlining your operations for efficiency or chasing after innovation to boost your productivity, the destination is all the same. We're all building towards an AI-ready foundation. All these innovations are all about driving sustained competitive advantage, capturing your new market opportunities, and accelerate your data-driven decisions. Among all this excitement, there is also concerns about what new risks are being introduced. Current landscape is fragmented, we all know that. There are complex security setups, tools inefficiencies, and also a lack of talent and expertise. These complexities are what you are challenged with and is also the enemy of security. And in the age of AI, fragmentation doesn't just slow you down. In fact, it leaves you exposed. So, how do we keep innovation and transformation secure without introducing new and unknown business risks because of AI adoption? The risk is actually more apparent than before with the rise of agentic, where agents are coordinating together, communicating, and also helping you to solve the higher order problems. These agents operate with very little human supervision. While it gives you autonomy and is powerful, it also introduces new challenges, where risk and security problems are further magnified and pronounced. We must address these security and trust issues before we fully realize their potential. Now, to understand how we can secure these agents, the first thing that we need to think about is let's look into the environment that they all lived in. As AI adoption accelerates, the underlying AI stack continues to grow in complexity. You can't just secure the agent. You have to think of AI as a whole ecosystem with 5 layers beneath that. You have your agent, you have the platform that's running on, the models that you adopt, the data stored, and not forgetting the infrastructure that it relies on. Crucially, we should also be thinking about securing these 5 layers because this has evolved to become your new attack surface. And it is not just a model endpoint anymore. In fact, this complex stack is what you're dealing with today. Reality is, attackers are already finding creative ways to exploit this complexity. We are seeing a whole new spectrum and category of attacks, which we have never heard before in the past. Things like prompt injection. Think of it as, how do I trick the AI to execute something beyond what it should be really doing? What about model poisoning? It's where you secretly tamper with the data that the AI learns from. Data exposure is really, with AI acting as a blabbermouth, it reveals more than what it's supposed to speak about. Things like your private, your sensitive, your confidential information. And this is not theoretical. There are real risks that organizations are concerned about because they are impacting the brand, the reputation, the trust that we have, and also the data sovereignty. Now, if you think of security only as an afterthought, this is really going to be painful because that would indeed slow and stall your innovation. Imagine the rollbacks you have to do because of a failure with your innovation. The decline in trust and confidence that cascades down with it. But if you do adopt an ecosystem that has security in mind, where security is baked in, is embedded by default, and by design, it makes it seamless to adopt security. This helps to become a true enabler of growth for businesses, reducing the friction behind it, and accelerate your digital transformation, and more importantly, your go-to-market. In Google, we built a unified and integrated experience with our Security Command Center, SCC in short. Think of it as a seatbelt for your cloud. It is the foundational security capability for Google Cloud. And if you're running any of the Google Cloud today without Security Command Center, you're actually missing a critical layer of protection, because the controls are built right to the fabric of Google Cloud to help you manage your cloud risks. Among all, SCC does many things, and one of those things that we're going to talk today is really about protecting your AI workloads. Primarily, looking at three different things. Number one, how do you discover where it gives you total visibility of all your AI assets? How do you manage the threats and vulnerabilities in real time? And how do you secure where you safeguard the models and data at runtime? So, now, let us break down and starting with visibility. Because you really cannot secure whatever you cannot see. That's the first problem that we are trying to solve with discovery. Security Command Center automatically discovers all your AI assets, be it your agent, your models, your data set across your environment. It builds an inventory that you can exactly see what developers are spinning up and down. That helps you to eliminate any shadow AI issues and risk by giving you a single pane of glass for your entire AI estate. But it goes a lot deeper. We can really scan for multi-cloud data assets to identify your personally identifiable information, your PII, and sensitive data. We will tell you this model is tuned to this specific data set which contains this sensitive financial information. And why is that so important? Because the lineage is critical when it comes to compliance. Now that you know where are all your assets sitting, let's understand the associated risk that is being identified. Within SCC, Security Command Center, there's a part that's called a capability that's called toxic combinations. If I put it in layman term, it means, example, if I leave your front door unlocked and I've decided to post on my social media saying that I'm on vacation, and you start leaving expensive jewelry or money on the table. Each of these might be risky, but they are manageable. But what if they all happen together? It creates a perfect storm that guarantees you a break-in. That's exactly what SCC is looking at. You might have very benign events that comes in, but when it comes together, that's where it becomes an issue that organizations need to tackle. Beyond that, Security Command Center identifies the attack path by conducting what we call a virtual red teaming. It constantly tests and stress tests your AI model to make sure that it doesn't get tricked, to reach out to critical assets and your sensitive data. It gives your team the first-hand information so that you are able to fix all these open doors before attackers can find them. Security Command Center further discover for all the hidden risk and vulnerabilities within your organization before you even go live. Now that we have done with discovery and management, all these are all about posture. What happens if your app is already live? This is where the runtime security comes in. And one of our most exciting innovations from Google Cloud is called Model Armor. Think of it as your firewall to your large language model, LLMs. It sits in the flow of traffic that inspects both the user prompt and the model response. And it eliminates the risks that we earlier spoke about. Things like your prompt injection, your model poisoning. In fact, because of SCC, you can even turn on filters that filter out hate speeches or toxic content. For business leaders, it really helps prevent data loss. So, it stops your fine-tuning of model from hallucinating and leaking of PII information in the response. And for developers and architects on the call, I would like to emphasize the flexibility. So Model Armor isn't just about Gemini. There's a flexible layer that can protect any model on any cloud. Whether you're calling out OpenAI on Azure, Llama on AWS, or Gemini on Vertex, Model Armor sanitizes all that traffic for you. It allows you to also create what we call a consistent security policy across your entire multi-cloud AI stack through AI posture controls. So you can define what secure looks like. As an example, you can create a rule that says any data that's used for AI training that's in my cloud storage must be encrypted. You might be wondering why. The reality is, in the real world, things change too fast. A developer might accidentally turn off a firewall, or maybe make a private data set public to test something really quickly. SCC, Security Command Center, constantly watches your environment. You can actually see what is changing, the rules that is drifting, and it informs you immediately so you are able to apply the fixes as soon as you can. Finally, we layer on top, the best threat intelligence from our Mandiant. So with this integration of Mandiant frontline intelligence onto the platform, Security Command Center can detect for any anomalous behavior that indicates an AI-specific attack. Things like your model theft, your data poisoning. It's really looking at what Mandiant sees in the wild and part of our incident response work. It allows your security operations team to detect and respond to threats that's against your AI workload in real time. Now, I do have a quick demo to show what SCC looks like. It really captures the inventory that we spoke about, providing you your foundational model and data sets. It gives you a risk view, providing your attack path. And for models that you have and decide to turn on Model Armor, how do you apply and mitigate the risk by applying policies like responsible AI? And finally, any kind of anomalous behavior, our intelligence from Mandiant will actually inform you of these. So, to sum things up, security innovation is imperative to all businesses, and Security Command Center with AI protection offers you the complete lifecycle approach. How do you identify assets and data lineage to our discovery? How do you manage your vulnerabilities and toxic combinations? And apply real-time protection to secure your AI innovation with Model Armor and Manual Threat Intelligence. We are helping you to build not just a smart AI, but also a safe AI. It unlocks the confidence across all your various teams. Google has also published some of our security best practices, on securing AI, the same way that we secure our own. These are all documented and shared publicly. One of them that I want to point you to is our Google Safe AI framework, which you can actually download through this QR code and this link on the page. We have also published some best practices that you can also download so that you can actually read into what we are doing. And for customers or for any of you who feel like you need more help, we have consultants who can sit down with you, look into your entire AI architecture, understand your workloads and if they are properly secured. For those who are already very confident, you can really test it by engaging Mandiant to do our red teaming exercises. It gives you an unvarnished truth of your entire AI setup. Last but not least, for any of you who is looking to use AI in your security operations, we've done that many times and we'll be happy to guide you on that journey. And with that, I thank you for your time. So let's go build the future securely. Thank you.
welcome back everyone. I'm going to get started with the lab portion of the Cloud Technical Series. So today I'm going to do this live lab, connecting your remote agents with ADK and also using the A2A remote agent to connect up another agents together. So let me quickly cover what we're going to do, right? And when you want to access this lab, and if you have not registered it, right, if you want to follow it along, you have to make sure that you have to be added to the classroom. This is only accessible if we add you into the classroom. And if you have not put in or registered for it, make sure you sign up at the link or scan the QR code that's showing on the screen right now. And you will need to also enter the dynamic OTP code after you have entered your email address. So you can't just enter email address and then access it. You need to go and retrieve the OTP code as well. So we will leave the link and the OTP code on the screen for the duration of the session. So anyone who wants to join in, you can join in, but make sure you scan this QR code and then sign up, right? And we have a lot of people joining us today. I'm so happy to be here. And also, please be patient if there's some delay. Don't worry, we'll make sure that the labs are stay enabled until 13th of February. So you have plenty of time to complete and get all the badges. You don't have to get on it right now. So I also encourage you to listen to what I say, explanation, and also go through some of the flow first and do the lab at your own time, at your own pace. You don't have to finish it right now to achieve the badges and all that. So don't worry about it, right? If you want to follow along, it's okay. If you cannot follow along, just make sure to listen in and see how the lab flows so that you can always come back to it at the same time. And of course, the lab will be recorded, so you can also come back to the same page after a few days to refresh your memories and then follow along if you want to. So don't rush, okay? It's okay. We are at the back end trying to fix all these issues that you're probably going to face. So make sure you sign up for it, get the OTP code, and we are ready to go. So before we actually go through this concept of the lab, right, I want to cover some of the basics so that not everyone is familiar with what agents are and A2A and so on, right? So let me go and cover the basic one. So the first one, what's agent, right? So think of agent as this one unit that contains large language model. You have tools and also the orchestration part. Comparing the analogy, right? Let's say if you are creating an artificial intelligence, you probably need to have a brain, which is the generative AI model, which is large language model, could be Gemini model, could be Gemma model, any model that you kind of want to use. And then of course you need hands and legs to do things with other things, right? Maybe you want to schedule an appointment, you want to call somebody, you want to email someone, right? So things like that, you could also use it through API, function calling. Maybe you want to retrieve some of the databases, information, and so on. You can do that, right? Vector search and other things is also part of that. And maybe sometimes you might also want to delegate your task to another agent. So this is where you could also use it with the tools, right? So now you have the brain, you have hands and legs to do things, but you need a body to house them all together. So this is where the orchestration piece come in. That ADK, the Agent Development Kit, cannot help you to do all these things together, right? It cannot give you the ability to put in your persona, how do you respond to your customer, how do you customize the responses, what kind of tones and so on is you can describe it in the orchestration tool. And of course, using the orchestration tool also allow you to have things like memory, like short-term, long-term, like what are the important factors from the customer that you want to store and stuff like that, right? And of course, when you want to do things like reasoning, chain of thought prompting and stuff like that as well, you could integrate into the orchestration layer. So this is what AI agent is, and this is what we are, moving forward in terms of the AI space. Is very powerful. Instead of just using one short prompt with the large language model, you are actually now using this whole system to do lots of things, right? The capabilities are being expanded through things like MCP, and now we have A2A and other things. So let's quickly cover what actually means to have the A2A. Right? Assuming you build an agent and your friends also build an agent. Maybe you guys are using different framework, right? You use, let's say, ADK framework. Maybe another person uses some other framework, right? Maybe you can see from here, you have using ADK, another agent framework that you're using. And maybe you guys also have the Model Context Protocol server to have access to APIs or enterprise application and so on. But the agents are actually built using different framework and maybe also do different functionality, different feature, different capability, maybe using different kind of large language model as a brain as well. So how do I make sure that those two agents can talk to each other? is by using something called A2A protocol. So A2A protocol is also open source, backed by Google. So we cannot have like a way for you to communicate your capabilities, your authentication process, what are the functions and skills that you have from different agents altogether. Something similar to like a changing name card, right? So when you go to a networking events, you want people to know that who you are, of course your name, right? How they can reach out to you, maybe email address, maybe what do you do, like your job titles, or maybe some of the skills, some of the website that you do, right? If you're like a creative person, maybe you link your portfolio website there, something like that. So if you go deeper down into what does A2A things does, right, it's like this, right? You have this agent card. We actually now using JSON to do that. So you can see from here, like, what's the name of the agent and who is the provider of this agent? What's the input-output preferred, right? So nowadays we have a lot of multi-modals models. So it can actually accept audio, videos, images, and so on, right? Not just text. But what if my agents can only process text, but my friend's agent can process images and video and audio, right? So I can definitely communicate my agent with my friend agent by only text, right? Because my agent has limitation in terms of processing the information in the text modality, right? So this is where you can do things like, streaming, it means like, passing the data in a streaming bit format, not just one-shot format, right? I can do things like push notification. What are the skills that I have? Maybe my skill 1 is to like book appointment. My skill 2 is to like cancel appointment, right? My skill 3 could be, something that maybe check the availability of the saloon or something like that. Right? Of course, when you talk to some agent might be free for all, right? Maybe they are like reservation agents, so you can talk to them if you logged in or something like that. But if you are maybe more working with an enterprise, you might have to have like an authentication kind of things to make sure that not everyone can access, right? Like we just talked about security. So security is also one important aspect of making sure that your agents are not compromised by different malicious users, right? So this is like a background knowledge before we get started, and the lab itself is going to do something like this, right? Assuming you have this construction company that needs to kind of like create different slogans with like images and so on, and you have this agent which is help you to create things like illustrations, images, and so on, but you wanted to make it central so that different departments can just plug in using remote A2A tools or A2A protocol to generate things like maybe I want to generate it for my slides, I want to generate it for my promo campaign, I want to generate it for different aspects of things that require graphics. They would then talk to this central illustration agent. Illustration agents will then generate the image and pass it back to the other agent, right? So you don't have to have like, all these different departments. Like in this case, there are like 6 of them, right? So not all 6 or 7 of them needs to have illustration agent built in their own department. They could have one that is housing, or let's say Cloud Run, and once everything is being hosted in like a central location, they could just use the remote A2A protocol to be able to communicate and get the things that they need, right? So then you also need a team to only focus on maintaining the illustration agent so that whenever they have some issue, you can only go back to the same place, right? This is what we're going to do. We're going to have 2 agents, slide content agent and illustration agent. The illustration agent will help to generate images whenever you connect, like let's say I need it for the slide, right? Then it will just like talk to the illustration agent, delegate the task, get back the output. Okay, let's get into it, right? To get started, you kind of need to go into this specific instruction, right? So listen carefully, and then if you cannot catch up, it's okay. Take it slow, and you can also watch the recording later, but make sure you follow the step and you don't get lost, right? So the first thing first, you need to create an account if you have not already on the explore.quillab.com. So once you create it, what's going to happen is it will actually bring you to this page that is similar to you if you're using something like a Outskill Boost or Google Skills or some other Quillab account that you are used to. But this is actually a different platform. So you need to create an account even though you probably already created some other Quillab account before, right? And creating an account is not enough. You need to be granted a special access to our classroom today so that you don't have to spend any credits to get into this lab. So the next step that you have to do is you have to check whether your account is already been added into the classroom. So if your account is added to the classroom, once you logged in, you should be able to see this purple box as I shown here with the red arrow, right? If you don't see it, make sure you check your email that you used to log in for this one is the same as the one that you register for this Cloud Technical series. So if you somehow register wrong email, maybe typo in there, make sure to register one more time so that you get access to it. And the same thing, right, that I covered before, the OTP gonna come in, you're gonna use the OTP to log in and stuff like that, right? So don't rush. If you're having issues, you can also check in our session in the comments to kind of figure out, and you can also reach out to our 24/7 help center at the corner, right? So if you go to the top, right, so probably around here, you can see there's a help button. Click it, there's like chat, help, like forum help and the comments and stuff like that. You can do that as well to make sure that you get access to this lab, right? So once you have access, however, you will see a couple of labs will be enabled for you, right? There are 4 labs for this particular program, right? So you want to follow along, and you've already seen this. Click this connect to remote agent with the ADK, and then using the A2A SDK, right? So if you click this one, what's going to happen is going to pop up like this, right? To the right, you can see from here, this is the page you will see. If you already have access, if you already have account, you can access to the classroom, you're added to it, right? So all these steps you're done, you will see this lab. And now, all you need to do is just click Start Lab, right? So once you click Start Lab, what it's going to do is going to procure the cloud environment for you, including creating things like buckets and some of the enablement of the API and stuff like that will be done backend. Be patient. It might take up to 1 or 2 minutes, maybe sometimes up to 5 minutes. So even if you can't get it right away, just be patient and wait for it. It will come in a bit. Okay. So once you have the running things all okay, you will see something like this where you will see like, hey, here's your student ID, here's your password, here's your Google Cloud project. If you can see it, you're good to go, right? So all we need to do is just right click on the open console, and then you can open as an incognito window, and then it will actually open up incognito window with all the logged in information available, right? So yeah, and for some reason, maybe like, hey, I have something to do. My mom's calling me, my wife calling me, whoever's calling, maybe your boss calling, I don't know. So if you have that, you can just end the lab, right? And then you just come back to it again by following the same step that we did, right? So even if you don't want to end it, there's the timer. Once 1 hour is marked down, it's going to end by itself. So you can't save the process, unfortunately. So if you want to end it, just click on the end lab to end it. But of course, we want you to finish the whole thing first, right? That actually gives you some badges and so that, okay? Right, so let's get started with the instruction, right? So I already kind of like run this lab to test out everything is working fine. First thing that you need to do from here, right, is that it kind of explain to you what A2A is, what kind of A2A server is, whether you need to install specific projects, also some agent card for you to describe the ability, right? At the same time, what the startup requirements and so on, right? So you can kind of read through it at your own pace. I will just go through some of the important points that you can actually use it to get started, right? So the first thing, it asks you to open, incognito window, start the Google Cloud Console and so on. Once you have it, right, it actually tell you about your student ID and also your password. Do not share those information. It's for you, right? And of course, don't copy mine as well. So make sure you use your own one and then you logged in, right? So once you logged in already, first thing, the task 1 is for you to install the ADK and set up your environment. So what you need to do is to click on the Cloud Shell Editor tab, right? So something like this, right? You will see some Cloud Shell Editor, right? So once the Cloud Shell Editor has been set up, right? Now I'm just like disconnected already, but what you need to do is just click on it and then type in this command, right? So Cloud Shell Workspace. Once you type that, you will be presented with the shell commands like this. Right? I'm going to just reload it for a bit, right? So it will ask you to authorize. Let's click authorize, and then it will present you with the Cloud Shell Editor. The editor has a similar environments as IDE up top, right? So from the top, you will see some code, and from the bottom is where you see all your command that you need to type, right? So for some reason, if your connection get lost, just reconnect it. It will just reconnect it at the back end, right? And for some reason you get disconnected to your project, you could also find your project ID over here. So this is the ID. And all you need to type down is, let's say gcloud config set project, then your project ID. It will then reconnect at the backend to your project, right? You can see it's connected. So how you know it's connected or not is through this yellow color text. So if the yellow color text is there, it's connected, right? So, and of course, once it's done, your instruction is to install the ADK and A2A SDK. Once you install, they will ask you to download some folder, right? So this one, you can only download it when you are starting the lab, right? If you don't start the lab, this instruction will actually tell you some of the information is not available, and you cannot download some random other people folder as well. So this is not public, so you have to then download it by yourself, right? After you've done it, once you have done all this, right, it will actually have this button of check my progress. You don't need to check whether you have all the process are being 100% correct. So then you have like, see, I earned the points to the lab itself, right? So you can always come back and see how many points you have. Now I have 100 to 100, right? If you cannot click this, for some reason it's giving you errors or not actually having, like you have not completed this task, and even though you have done it already, just give it like 2 minutes, refresh it, come back here again to check, right? So it should be quite straightforward to just click and done, because this is just to install ADK, right? Some people might be creative enough to go and create like a virtual environment and then install it. It might give some troubles in getting this setup environment. So if you are doing that kind of things, make sure you are following the instruction, because it's kind of detect the base environment and to see whether that the ADK and the SDK being installed inside there, okay? So don't be creative and start creating virtual environment. This is gonna be kind of like a virtual by itself anyway, because this instance gonna get deleted for me in like 13 minutes, right? So don't worry about not having virtual environment, separate environment, and so on. Okay, now go down to exploring the ADK agent, right? So what's going to happen is we will just explore the code that we have here, right? So it cannot tell you to go and open up A2A. So this particular folder, we downloaded from here, right? So this is where we download it. We will download from the bucket. We will then unzip it. Then we will get a folder, right? So the folder looks like this. Let me actually close it up, right? This is the ADK and A2A folder, and you have something called illustration agent and then slide content agent. So illustration agent is responsible for creating graphics, right? So let me show you what the agent.py looks like over here, right? So first thing, of course, just load the environment and all that, but the first thing that you notice will be generate image function. So this function acts as a tools to the agent to generate the image as per illustrated request, right? So what it's gonna do, it will just like the prompt you can see, it just use the model, which is the image model. The image model now we are using Gemini 2.5 Flash image model, and then you just create image as the response modality. The aspect ratio is 1:1, which is a square one, right? And once you have it, it will actually have the bytes from the response. You will then use those bytes, store it into the cloud storage, and then return the link of that cloud storage. You see? Return the public URL. So in this agent, it doesn't return the image itself, it will return the link. So then you can click the link to find the image. I will show you the result in a bit, right? So the agent code is very simple. You have the ADK agent, right? And then you have the name of the agent, what model we use. We can use 2.5 Pro, 2.5 Flash, 2.5 Flash Lite. If you are adventurous, you can also try Gemini 3.0 Pro and Flash. They are still in preview right now, but you can try it. You can see the instruction here, right? So you are illustrator using for the stadium maintenance company, right? You will see a block of text, could be company slogan, could be marketing campaign requirements and so on. The task is we are kind of like scoping this into company branding, right? So you say we prefer the flat geometrics, corporate kind of style of art, and the palette for the brand is purples and green, right? So here is very important, right? So purples and green have like different shades, right? So then you need to provide accurate hash value, right? Or RGB or hash value so that the agent know exactly what type of purple is considered a brand purple, right? So Google has like 4 colors, right? It's of course, not every blue is Google color, something like that, right? So then you have to consider the clever and charming approach. And you can incorporate some of the images like, lights, like a green field, popcorn, because this is a stadium company, right? And of course, maintenance images like toolboxes, overall, people wearing overall, and also some kind of sport themes like balls, caps, and gloves, right? So this is to show you that once you put in the brand requirement, the agent will actually adhere to those brand requirements and try to generate images based on that. Right? So this is how you can influence the way images are being generated using the image flash model. Okay? So you can see here, once you have written the prompt, use the tool, which is generate image function upstairs, to generate an image and always return two things: the text of the prompt, so which prompt do you use, and then the generated URL. Right? So by providing this tool, your agents will then return two things: the prompt and then the result image that's stored on the cloud storage. Okay, so I will show you how it looks like now. You can see from here, this is what I asked, right? So by supporting each other, we get big thing done. So this is like a company slogan, right? So agents will then take it and then try to say, oh, this is like a company slogan, right? Let's try to generate something like this. So this is the image prompt. Maybe I will just zoom in a little bit to see. That might actually make it easier for you to read. Zoom in here and then scroll up here, right? So this is the image prompt. Then use the image prompt with the function of generate image. So generate image, then use the prompt to generate an image, and then it gave me the image on the cloud storage, right? So image just looks like this, right? Remember we added balls, wenches, toolboxes, popcorns, stadium, some sport-related thing. That's why it's like that. Of course, when you generate it yourself, you might not exactly get the same image, but you will get a similar one somehow, right? So even you check the lab, right? It actually doesn't have a similar one. You can see it's stadium with like some people wearing overall and stuff like that and popcorn, but you won't exactly get the same images all the time. Okay? So it also asks you to check the prompt that you use. It didn't mention anything about sport, stadiums, or maintenance work, right? Because we just put in a slogan, right? By supporting each other, we get big things done. Even though we just put that, because we already put all our branding guideline and everything in the agent instruction, right? It will then use the agent instruction, complement to whatever we put it in, and then we can just get these images, right? So this is where you have tested your illustration agent working in local environment, right? So this is still local. What we're gonna do next is to deploy this agent as an A2A server, right? So remember the A2A server that I kind of like covered in earlier time. You need to create this agent.json, the agent card. So what does agent card include? So agent card includes a similar thing: name, description, also what type of input does agent accept, what type of output the agent will provide. In this particular thing, we will accept the text and then we will output JSON format, right? So what kind of skill that we have? We can actually generate illustrative things to mean whatever that provided from the user, right? And we will tag it as illustration and image generation. So this is a URL. It's like an address or maybe like an email address for your name card, right? Same thing for agent. So agent doesn't have name card, they have agent card. So the agent card actually point to the Cloud Run's URL, right? So this one you will get it when you deploy it on the Cloud Run, right? So this is like a Cloud Run URL. So once you have this JSON file, you can actually start deploying, right? So once you have the JSON file, there's like an agent requirement, agent card, and we just need to have this Python requirement text so that once you are uploading it to the Cloud Run, it can actually install the required packages to run this particular agent, right? So once you have that, all we need to do is to run, right? You cannot explain what project is, what region is, what server name is, and we have to make sure that you have this flag called A2A so that it knows it's gonna start this particular agent as an A2A server, right? If you don't include A2A, it will just start as a random, normal Cloud Run server, and then you might not be able to connect up using the A2A protocol. Remember to add in the A2A flag, right? So you can see from here, this is the complete code of ADK run deploy, and then the project. So this one is your project ID that you receive from here, right? If you're trying by yourself with your own particular account, maybe your work account, student account, your personal account, the project will be different. And then the region, you can set on the region that you want to do as well, right? Once you have the service name, so this is where you will see the service name, actually reflect on the service name that you kind of type it over here, right? So illustration agent, then you will get reflected by this one as well, right? Then you just, so this is actually the folder name that you want to run to, right? So this is the folder name that you can see from here. Let me show you. So this folder name, right? So if you want to deploy, let's say, slide content agent, you need to put in slide content agent as the folder name over here, right? It will then package the whole file, send it to Cloud Run, host it at the A2A server, okay? So once you have this already, you cannot have like, okay, it might take maybe 5 to 10 minutes depending on how fast the thing, right? It also gonna ask you something, right? So when you run it, it will actually say, hey, do you want this to accept authenticated or not authenticated requests? Because we're just testing here and this environment is temporary, we can just say yes for that. And if you are going for production, you need to say no, and then you need to configure the authentication part yourself, right? Remember, security is important, right? So once you have everything set up, you will say, hey, your A2A server is ready. Here is the link that you can access, right? So once you have this you can actually check whether the agent A2A server is correctly hosted, okay? Once it's hosted already, what you need to do is, now our illustration agent at this point is hosted on the Cloud Run, right? And what we need to do is to use another agent to call the agent that is hosted on the cloud by providing instruction and then receiving that JSON, which is also the link, the image prompt, and then also the link of the result image, right? So to do that, we have to have the agent card, right? So how do you know, or how do you contact someone you met at the networking event? You need to have their name card, right? Maybe your LinkedIn profile or social media or maybe phone number, right? Some way or another, you need to have their information before you can talk to them, right? So this is where we need to create the exact same copy of agent card, right? So it's actually copying this thing called illustration agent into like a name card itself, right? So this particular JSON file is residing on the cloud already, right? So, but we have the copy locally because we are building things by ourselves, right? So just assuming maybe this particular JSON file is owned by another department, right? Maybe your IT department. Then you transfer it to you, then you can use it as a way for you to communicate, right? Because this is where it gives you what the URL, what are the functionalities, and what's the name, who owns it, and so on, right? So then what we need to do now here is to edit the agent.py from the slide content agent. So once you have that, right, you can see the difference between illustration agent initializing from the first code and the second code is this remote A2A agent package, right? So I will actually tell you how it looks like, right? So for the agent itself, we can just use the LLM agent or the agent package. But if you are talking about slide content agent, because we are calling it to the cloud, you need to identify a remote A2A agent. It's no longer agent, right? If you just use agent, it's going to be local. If you use remote A2A agent, it will be calling to the remote. And of course, you have to provide the agent card, right? So this agent card is what we copy, is the exact same card or exact same JSON file that we uploaded to the Cloud Run, okay? Just remember that. Okay, once you have this agent already, what they say is you also have to put this agent, the remote A2A agent, as your sub-agent so that this particular slide creation content agent can delegate the task of generating illustration to the illustration agent. I hope that makes sense, right? So once I have this agent, illustration agent initialized it, right? I can just pass it as a sub-agent over here, and then I will just run it, right? So once I have run this thing, what's gonna happen is I say, okay, create a content slide for our job, excellent job training, right? So the first step, it will say, hey, I received this request. What I can do is I can create the headline, I can create the body, but I do not have the capability to create image, right? So I will check whether any of the sub-agents can actually create image, right? Illustration images. So remember, the agent card that we have is actually have this scale portion. It actually tells you that it can do image generation and illustration, right? So this one will be taken into consideration when the agent deciding which tools or which agent to delegate to, right? So from here, you're like, oh, I actually have a sub-agent that I can delegate to, that it will actually use this transfer agent function, that is transfer the agent. So once the agent is, the control is being transferred to illustration agent will take in the input prompt, right? And then generate the image prompt, then generate the image itself, okay? So this image results looks like that. Okay, this is like on-job training, illustration, similar things. But that's kind of the gist of it, right? So, so now let's say another department or another person wants to come in and then, hey, I want to also do something similar, right? Maybe I want to create it for my video or maybe my social media post. Then I can create something like a social media agent, use remote 808 agents using the same agent card to connect to the illustration agent and then generate illustration for them, right? So that's pretty much it, right? So you can get started and then you can actually check whether this particular thing's working for you. There might be a time where you see something like, oh, your resources have run out, you don't have the quota to run things, blah, blah, blah. Just wait for a few minutes and try it again. And what can you also do to improve your chances? I will give you a tip, right? So let's go to this environment file that you will be creating as part of the lab, right? You can actually change the location. So these particular things for the slide content agent, I'm using a global location, but for the illustration agent from here, environment, I'm using US Central 1, right? So if you kind of switch the region a little bit, it's easier for you to get a little bit more quota, right? Of course, not everyone changes the same thing, right? You can always go and find out which region is closer to you, blah, 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 and you can change it, right? Some people also change something Flash to like Flash Live, for example. Different model, different quota, you can try it out, right? So just play around and see whether that actually help you resolve some of the issues that you have, right? So don't have to just like keep, getting pissed off at this. Try to be creative and play around with it to understand, and also try to get some workaround to make sure it works, right? And for some reason you don't want to do that, just wait for a few minutes and try again. It should be good, okay? Yeah, so I think that's pretty much what's happening, and you can kind of get a similar output, right? You won't get exact same image, but you still can get something similar. And once you have done it, check for the progress, and you'll be good to go, right? So this is the end of the lab for this one. If you have any problems, you can always click here to get the help center, email support, chat support, and so on as well. Right. Not only that, we also have the the Gather platform has some other ways to comments, and you can also get a help from there as well. Okay, so some summary. Remember, we cover a couple of things. What's agent? What's A2A? How do you use A2A? What kind of use cases you can have? How do you how do you host your A2A server on Cloud Runs? And how do you use agent card to communicate between two agents that is developed by maybe a separate entities and all together? And a few things to recap is, if you complete all 4 labs in the classroom before 13 February, that's like a few weeks from now, right? You will receive a special Credly badge, right? So this one you can show it to your LinkedIn, your friends, and so on. So, but whenever you finish it, don't just leave the lab open, right? So once you finish all the instructions, make sure to click lab so that you can ensure it. And also check this one. So if you see 100 to 100 over the right side, then you're good to go. Just end the lab and then should be okay, right? So there will be also 2 more labs tomorrow. If you miss some of the lab today, it's okay. You can catch up the lab, right? So the entire show become watchable maybe about 2 days from now. You should be able to see the recordings, right? So good luck, and then happy learning, everyone. Something like that. So, hello everyone, welcome back to Ask the Expert question. So, we have Chandrika, May, and Kaz, your speaker for the evening and the morning session. We have some great question that asked by the audience. We're gonna go through them one by one, right? So, first question is to you, Chandrika, is that does ADK force me to use the same model all the time?
So absolutely we can mix model. It doesn't force you to do, use only one model. So in ADK, if you see, every agent is an independent object. So for example, you can configure your top level router agent to use a Gemini Flash model. Say for example, a lightweight and cost efficient model, just to classify, for example, the user intent. And hand off the difficult task to a sub agent running a Gemini Pro, more, bigger models. You get the intelligence of the big model only when you need it, significantly lowering your average cost per interaction. So this is the recommended design pattern, I would say.
I see. So you can kind of like switch around different agent, different model, some image, some text, some better, some more thinking, so on. Awesome. So the next question we have is for May.
Me.
So there's a long question about live chat, is about CX Agent Studio release date. So can you tell us more about when it will come into GA?
Yes, I've been getting this question not only today, but from other colleagues and customers. So while CX Agent Studio is not generally available, it hasn't GA'd yet. But Google Cloud recently announced this same product, CX Agent Studio and Gemini Enterprise for CX, just a couple of weeks ago at NRF 2026. So I'd say there are some exciting updates coming soon, so please stay tuned. That's all I can say now.
Yeah, stay tuned at the blog post and announcement and so on. Right, so the next question is, targeted to Kaz, right? So you cover vector search and so on. So what's the difference between Vertex AI search and Vertex AI vector search?
Yeah, this is the one of the frequently asked questions that everybody is confused. So I've talked about the vector search today, and that is originally intended for the data scientists and machine learning engineers. So even though with the version 2.0, it changes to be super easy to use, so you don't have to care about the embedding everything, but still you have to understand what is embeddings, what are vectors, and how to use those things. Whereas the Vertex AI search is another product That has everything's inside the product, but the user don't have to understand the details of the embeddings or vectors and everything.
Right.
It's all encapsulated, packaged. So all you have to do is just upload your PDF files or CSV file on the cloud storage and let the product building index automatically. So that's the difference.
I see. So am I right to say that Vertex AI Vector Search is more managed solution for the user?
Yeah.
Oh, that's interesting. All right. So now we actually have questions from Iman to Chandrika. Okay. So the question is, are custom agents in ADK private, and can it be based on proprietary information that is securely across GCP environment?
This is probably the most critical question for any enterprise to adopt the AI agents in their day-to-day workflow, right? The short answer is yes, they are fully private. First, you retain full ownership for your data, any questions or response, basically any interactions that you have with the agent, and your agent code, that whatever code you have developed, right? All stays isolated within your project boundaries. So we enforce the principle of least privilege by specific service accounts. So the agent only sees what that specific human user is allowed to see. So we use secret manager to handle API keys, so they are never hard-coded. And for network security, we use VPC service controls and private service connect to ensure the traffic between the agent and your data. So to put it short, GCP is the go-to environment for data sovereignty, IAM, and infrastructure security.
That's an amazing answer. So yeah, make sure to use GCP. Right. So the next question that we have is from the Chanvir to May. I'm so sorry if I'm pronouncing your name incorrectly. My apologies. Right. So the question is, what are the best practices for grounding customer agent in enterprise data? Could be CRM, tickets, knowledge base, and so on, while also ensuring the responses are still accurate and hallucination-free.
Okay, this is a very interesting question. Thanks for this question, Chanvir. I'd say, in short, give a good brain or good process and equip with a good tool. So instruct it well and give it a good tool. The most important thing when you build an agent is writing the clear instructions, and you should use the built-in tools to refine the instruction and also struct them effectively. And in addition to that, you can simply equip your agent with good tools, meaning leverage our native integrations for Salesforce, for CRM, and ServiceNow, or even use Python tools and also callbacks for runtime control, and use data stores to ground the agent and your enterprise knowledge. So also don't forget about the guardrail feature.
Yeah, so there's a lot of things that you can use to leverage, right? Grounding, guardrails, data connection, so on and so on. It's amazing. Thank you, May. So the next question is from Uday Hase. Sorry again. Is Vertex AI Vector Search 2.0 only work for structured or tabular data? Something like a SQL.
Okay. So actually the answer is no. It can also support the non-structured data as well. You can just define the ID in the data schema and define a vector schema for the embeddings of your non-structured data like text or images, and that's all.
Oh, okay. So yeah, you can use it for many type of data, not just the structured one.
Yeah.
Thank you for the questions. Let's move on to the next one. Is Chandra Shekhar coming back to May again? So May, you're popular. So how do you decide what decision an agent should make autonomously versus one it should escalate to a human?
Okay. I think I want to rephrase the question. Your agent won't be 100% autonomous, but it will behave as instructed based on the tools and the instruction that you have injected. So given that, I suggest focusing first on the tasks that drive your highest traffic, like your FAQ or the topic that are mostly contributing to your average handling time. This lets the AI agent to handle the repetitive high volume stuff autonomously with low latency. So your live human agents can focus on the complex, high stakes decisions. Whenever things get too sensitive or out of the scope, this is the time when you expect your live agent to jump in so that your virtual agents can hand off and get handed over to the live agent with the full context to a person to ensure a seamless experience. Hope that helps answer your question.
Yeah, so important tasks, human, not so important, let them do their job, kind of thing, right?
Yes.
All right. So the next question that we have is from the Chintamani Santosh. Is to Kaz. So how would you combine sparse embedding, like a keyword search, with a dense embedding, semantic search, to build a robust hybrid search solution? A lot of search in this particular question. So how would you answer this question?
Yeah, thank you for the great question. So for this, today's my sessions, I discussed about how it's easy to build a hybrid search by using the built-in semantic search and keyword search. So with the default setup, you don't have to build your own sparse embeddings at all. But if you want to bring your own sparse embedding by using TF-IDF or the BM25, then you can easily import them into a vector search component and build a hybrid search setup. Yeah.
That's awesome. Yeah, so you don't have to just use one. You can combine them, based on your use cases.
Yeah.
Awesome. So the next question that we have is actually from me. So now we kind of talk about a lot of agents and vector search and databases and so on. So what technology development are you most excited to see in 2026? Chandrika, how about you go first?
So basically, I'm more excited about the AI agents and humans working together so that, your productivity increases so that humans can work on very important tasks rather than mundane autonomous things that a simple agent can do, right?
Yeah.
So human and agents work together to make a great world. Yeah.
Oh, okay, that's exciting. How about you, May?
I think you might have expected this answer, but I would say CX Agent Studio going live, as well as I want to see that applied to your business and our audience's own websites. So I want to see that going live and then being used by our users.
Stay true to what you preach, yeah?
Yes.
How about you, Kaz?
Yes, so today I discussed about how to build a basic foundation for the agentic RAG by combining ADK with the Vector Search 2.0. So I'm so excited to extend more about the advanced the agentic RAG by adding a more sophisticated query generation or adding more the workflow management. So those are the most exciting topics for me. So I'm eager to write more blog posts and sample codes this quarter or maybe next quarter.
Yeah, so make sure to follow Kaz for the latest and greatest blogs that are coming on his Twitter and other things. So for me personally, I just want a robot to help me do my house chore, like cooking, cleaning, washing stuff. Yeah,
I want that
so
too.
let's see whether that actually came into the picture in 2026, right? So that's kind of all the questions that I have. Thank you so much, everyone, Chandrika, May, and Kaz, for being here after you have delivered your session already. But we always welcome all the questions, right? If you want to ask or if you want to be selected in this kind of, Ask the Expert session, make sure to put Ask the Expert before you ask the question so that we know that you're asking the expert. So with that, we're going to end this session. And thank you so much for tuning in, and I will see you in a bit. Hello again, everyone. That's a wrap on the technical session on day one.
I don't know about you, but I feel like I've learned a lot. We've covered everything from building agents to securing the infrastructure they run on. So many things.
Yeah, it was a marathon, but an energizing one. So, following along with the session for today, it really hit me on how much the conversation has changed over the last year, or even from the just last our Cloud Technical Series edition, right?
That's right.
Yeah.
We saw it in the ADK and Cloud Run sessions. We're not just building chatbots anymore or one-page applications. We are building digital workers. These are agents. These are systems that can reason, plan, and execute tasks autonomously.
Yeah, and they are removing so much frictions, and the security session remind us that with great powers come great responsibility, right? So when you give an AI agent the ability to execute code or call API, security cannot be an afterthought. It has to be baked in from the line one.
Of course. And how much fun was the Ask the Expert session just now? You were all smiles and questions about AI, agents, ADK, Cloud Run, and so much more. Security also were such an interesting indicator for what the industry will be trying to crack next.
Yeah, definitely. So on that note, let's have a look at how our audience do the quiz result, shall we?
Yeah.
So the first one.
What is a key advantage of using Cloud Run as a serverless runtime for running AI agents? Oh, it's
Could yeah, anything is possible, but what would you choose?
I think it's option C. It provides automatic, on-demand, and rapid scaling of instances.
Yeah, so when we see Cloud Run, we see scaling. Sure.
Yeah.
Right. Let's take a look. Well, you're right.
And
So
the audience
yeah,
are right too.
most of the audience got it right. So let's go to the next question. Is multi-agent system like one A2A is better than MCP and when? Like,
I think it's when we are negotiating with another agent. So basically, option C.
yeah, it could be that, right? So let's take a look.
Yeah.
All right. Wow, 2 for 2. Okay, so yeah.
Cool. That's the end of the questions for
Yeah.
now. And today we've covered the build and deploy phases of the agentic era. And tomorrow will be all about AI agents, from the developer experience to connecting your critical data.
I'm so excited about the lineup, right? For tomorrow is about develop with AI agent tracks, and I will introduce, you will introduce like Gemini 3.0 Pro, and also we explore the future of coding, tools like Gemini CLI, and also Google Anti-Gravity.
Oh, I can't wait to see the live labs, particularly the one where you build a dynamic website with Gemini CLI. It's a great way to get hands-on with Gemini to troubleshoot bugs and build applications.
So true. But then in the connect data with AI agent track, we will show you how to turn your databases into like active part of your AI stack. Like how do you simplify your data architecture with BigQuery, or how to actually build intelligence agent grounded in your own enterprise data.
Also, the multimodal data science live lab presented by yours truly. It's going to be another massive day that you won't want to miss. So thank you so much, dear community, for joining us on day one.
And another huge thanks to all the experts who put today's content together. I've learned so much, and that's saying a lot because I work with these kind of tools every day.
Oh, and there's another important takeaway before we go, is that you don't need an extensive tech background to start leveraging agents. You can just pick up from wherever you are in your career. And we hope you'll continue to upskill as the agentic era evolves at pace. We have a whole range of learning opportunities at Google Cloud.
Yes, like Google Skill. So we are giving you 300 complimentary training credits by joining us today. So this is where you can access or complete the lots of lab, just like the one that our trainer took you throughout the day. But you have to be quick to claim them because the space are strictly limited. So keep an eye on your inbox for all the details arriving in the next few days.
And of course, if you complete all 4 of the labs presented across the 2 days of our program, you'll receive a special Credly digital badge as proof of your new knowledge. Whether that's live during the program with our trainers or over the next 2 weeks, the badge will be automatically issued to the same email address you use to register for the labs.
So Abhi, this is one of my favorite one. Like it's a completely new opportunity for our audience. We are launching a new educational sprint for developer and the decision maker alike. the initiative called GEAR. So the GEAR initiative is for anyone who is wanting to learn and build and deploy AI agents. So if you're interested, you can register your interest using the QR code presented on your screen right now.
Oh, yeah. A personal favorite of mine is also the weekly webinar series. You can easily fit these short episodes into your daily schedule on demand or live, your weekly schedule, I mean. If anything sounds like it'll hit the mark for you, all of these opportunities and learning pathways are in the resources tab for you here in this platform.
And remember, if you have joined 5 or more of our session today, or you plan to do it by tomorrow, you will also earn a Google Cloud Digital Badge. So each Cloud Technical Series has its own edition, so you can collect them all and then display them on your LinkedIn, right? And look out for an email from our partner, Credible, in the next few weeks of the show, so that you can receive an access link to claim your onboard edition badge. And if you're ready to move beyond what's happening to start mastering the how, you will also want to clear your calendar for 17 and 18 of March. We are officially launching our next Cloud Technical Series, AI in Action Edition. Right, so scan the QR code now and register so that you can secure your spot. And I just know that you also like to give a final shout out to a learning opportunity that you're very close to, Abhi.
Thanks, Thuya. You're right. Yes, Code Vipassana. It is a technical initiative, a practice-based system that helps engineers and practitioners build deep focus and technical mastery in the ever-changing AI era, where you get to build data and AI applications and architectures for enterprise-grade use cases with the latest and greatest in data, AI, runtimes, and so much more. If you'd like to sign up, go to codevipassana.dev or scan the QR right here to register. All right, I can't stress enough how much we appreciate your feedback. If there are sessions you loved, topics you want to learn more about, or any comments about today's event in general, we'd love to hear your thoughts. You'll see our feedback survey up on the right-hand side of your screen right now. Please take a few minutes to fill it out. It's quick and easy and goes a long way for our team.
We hope you really enjoyed today. Even you get exhausted from learning so many things, right? So now is the time to rest up, and we'll see you back here tomorrow.
Thank you so much for tuning in today from all corners of the world. See you in the morning, Singapore time, 11:15 a.m. sharp, tomorrow.
Yeah, thank you everyone. Have a wonderful evening. Bye-bye.
Mm-hmm.